Hey guys, welcome to the final video in our series, in our topic on financial maths for year 9. Now, in the previous video, we looked at the depreciation formula, and a while back we also covered the compound interest formula. In this video, we're just going to use what we learned and the formulas we derived to actually just work through some questions in which we want to use these two formulas. Now, we're going to do one question for each. So one question for compound, one for depreciation. And then we're going to do a slightly trickier compound interest question, and we're going to see how the question and our approach changes when the frequency of compounding changes. Now, don't get too caught up on that. We will address it all in due time. But for question 1, we're going to go with a compound interest formula. So someone has invested $10,000 into a bank at a rate of 7% per annum, so per year, and this is compounded annually. So this is going to compound at the end of each year. So from the example we did in the compound interest video, we can just use our formula normally. And we want to find, part A, the value of investment after 5 years. And question B, we want to find the interest gained. So, if we remember our compound interest formula, it tells us the total amount that's left in our investment. So it takes into account the original amount of money deposited in, the principal here. So if we recall our compound interest formula, this is that our compound interest, our value, let's call that V, equals to the principal multiplied by the original amount of money, so that's our 1, and we're adding our rate here. So because our thing's going to get bigger, so we take into account the principal, the original value that's given by this 1, and we're adding the percentage of the rate here. And what we're doing there, and we are also going to raise that to the power of n, the number of years. So this is a pretty standard question you'll get. All we're doing here is substituting into the actual formula. So here, my principal is my starting amount. That's my 10,000. So that's going to go in here. So, whoops. So my 10,000 is getting multiplied by 1 plus my 7%. So that's going to be 1 plus 7%. I can write as 7 over 100 to the power of 5 years. Now, some textbooks and some teachers are quite picky with you writing the percentage. Sometimes they like you to write it as a decimal as well because it's easier to work with, and when you're putting it into your calculator, it's slightly less messy. So 7/100ths as a decimal, just 7 divided by 100, that's going to give us 0.07. So when we plug this into our calculator, now we can either write it as 1 plus 0.07 or just 1.07. I'll give you the option. You can do whatever you'd like. I'll just write 1.07 here to the power of 5. And we get here $14,025. So 0.517 ... Now remember, with money, we want to round to 2 decimal places, so it gives us an answer to the nearest cent. So this we're going to round up to 0.52. This is the final value of my investment. So we'll write here final value of investment. Okay, so where does the interest gained fit into all of this? Well, the interest, the money we got back from the bank on our investment, well, that's just going to be the difference between our price we ended up with, the value of our investment, the difference between that and the original amount of money we deposited. So the interest gained is going to be the final value of the investment minus the principal, the original value of our investment. So this, we can even make a formula out of it. We can say the interest equals the final value minus the principal. So we're going to take my $14,025.52 and we're going to subtract 10,000 from that. And that means the difference, the amount that actually accrued, that we gained in interest, that is going to be $4,025.52. This thing here is not my final value, it is my interest gained. So remember, the compound interest formula gives our answer, spits back an answer with the principal included. It is the final value of an investment. In the same way, a depreciation formula gives us, for example, the final value of a car or something like that after a certain amount of years. So the answer we got in part A isn't the interest, it's the final value. This is how this differs from the simple interest stuff we did in last year's course. When we deal with compound interest, we're looking at a final value of the investment. And the interest gained, that is the difference between our final value and our original value, our principal. Now, let's do a depreciation question here. So let's say, for question 2, that you have bought a computer 3 years ago for $5,680 for a computer 3 years ago. Okay, so you paid this, and we assume, for example, that the value of the computer depreciates at a rate of 25% per year. So per annum. Okay. And we want to find what the value of that computer is at the end of the 3 years. So we got this 3 years ago. We want to find out, all right, if I want to sell this computer today, then how much has this depreciated over the 3 years, after 3 years' time? So we're going to do a very similar thing. We're still going to look at our depreciation formula. Just realized I wrote rat, not rate. So we are going to, our new value is going to be, once again, our principal. And that gets multiplied by our original value, 1, our whole, minus the rate of depreciation. Remember, we want this thing in the brackets to be a fraction or a decimal or percentage, some kind of portion of a whole. Because that means that when we multiply, the value is going to go down. Anytime we multiply by a fraction, our value goes down. And this is to the power of the amount of years we had. So once again, all we're going to do is plug in the values here. So I have my principal, that's 5,680, multiplied by 1 minus my rate, so 1 minus 25 over 100 to the power of 3. And let's just write this as a decimal so it becomes neater when we put it in our calculators. So 0.25. And plugging this in, we get, once we look at our calculator and we put this value in, we are left with $2,396.25. So this thing here, this number we found, is the value after 3 years. That is our answer. Okay, we'll do one more question for today. And this is where compound interest trips up a lot of people. Now, that's why we're going to go through this quite slowly, just so you can hopefully build the intuition and see why the changes in values make sense. So, someone has invested $6,000 at 8.4% per annum, so still per year for 4 years. And we want to find the final value if the investment, instead of compounding every year like all the other questions we've dealt with, if the investment compounds monthly. So not just 1 year, we are looking at something compounding every single month. So let me write my formula first, just so it's here. So P equals, whoops, not P. Let's just write V for value equals the principal times 1 plus the rate to the power of n. Okay, now let's look at how each of these values are going to change. First of all, which one's not going to change? Regardless of something being done compounded monthly or whatever, the one thing that's never going to change is the money we started with. No matter how much these things compound, the starting value, whatever we invest, is always going to be my principal. So here I'm going to write my principal equals $6,000. Okay, now let's consider the rate here, because my rate that I'm given is 8.4% per year. So let's actually write that on the side here. My rate is 8.4% per year. Okay, now if this is the rate per year, I want to find what the rate is per month, because my thing is compounding every single month. So my rate is going to change from a yearly rate to a monthly rate. Now, how can we do that? Well, 8.4% per year. Another way we can write that is 8.4% per 12 months, right? Because 12 months and 1 year are the exact same thing. So it's the same period of time, just written slightly differently. So to get to a monthly thing, well, I want to find what my rate is per month. So what am I going to do? Well, I'm going to divide both of these by 12. Because to get from 12 to 1, I can divide by 12. So dividing 8.4%, or we can write that as a decimal because it's easier to write down and put into our calculators. Dividing by 12 is going to give me 0.0 0.007 per month. So that becomes my new rate. So 0.007. Now, in the same way, we can think of our years that have passed, because the N here, the formula is a little bit misleading, because you think of N and you go, okay, N is the years, right? But we can think of N more as the time passed with each compounding thing. So if, for example, I'm looking for a value at the end of 4 years, I'm looking at something that is compounded 4 times. If I'm looking at the value, for example, in this question, the 3 years, the amount of times that the value has depreciated or compounded, depending on the question, is that number of times. So when we approach something like this, we're thinking, okay, well, I've got my new rate. What's my new amount of times something has compounded? Well, 4 years have passed, and there are 12 months in a year. So the amount of times something compounds, if it were to compound monthly per year, is 12 times per year, because there are 12 months in a year. So we can say something compounds 12 times per year. So if we wanted to find how much it compounded every 4 years, we can approach this rate in the same way. So per 4 years, because that's what's being asked in the question. Something's been given for 4 years. So I can find how many times this has compounded for the 4 years that I need it to. And I can do that by multiplying by 4. Here and here. So I wind up with 48 times this investment has compounded per 4 years. It's compounded 48 times in the 4 years. So my N is going to be not 4, it's going to be 48. Because there are 48 times my investment is compounding. Therefore, the values are going to change. My formula still looks the same way. It's just the values change depending on how often my investment compounds. So what I'm going to do is I'm just going to find, in order to find the value of my investment, the final value, that's going to be, let's do an equal sign, my principal, so my 6,000 times 1 plus 0.007, because remember that's my new rate, that's my monthly rate, to the power of 48, the amount of times this thing is compounding. And if I put that into my calculator, I get a final amount of $8,386 and, oops, sorry everyone, bear with me. Right at the end too, that's annoying. Okay, the final value of my investment is going to be $8,386.21. That is how the compounding frequency changes the approach to the question. So just for one final little thing to think about, what if, for example, let's say there was a part B. So we wanted to find the value if the investment were to compound quarterly. How would that change? Well, remember my principal stays the same. My principal is 6,000. My rate now, so this is compounding quarterly. So 4 times, remember when I have a quarter, I'm splitting something into 4 equal bits. My rate is going to be my 8.4%, and it's going to be quarterly. So I'm going to divide this by 4. So my new rate is going to be, let's write it in a decimal, 0.021. 0.021. And my number of times this is compounding is going to be my 4 years, but it is compounding quarterly. It is compounding 4 times a year. So we're going to take this 4 and we're going to multiply that by 4. And we get 16 as our answer. Because it's compounding 4 times each year. For 4 years, that gives us 16 times this thing's compounded. And then the same thing happens when we just plug it into our formula. The formula never changes, just the values end up changing slightly. But you can have a go at a couple of these. So if you wanted to at home, using these same principles, you can find if this was to compound, let's say every 6 months. You could even find the value of this if it compounded daily. You can even have a play around with these at home in your own time. I'm not going to do them here because I'm conscious of time, but just think about how many times would this thing compound in a year? How many times would this compound in a year? And how is that going to change the rates our value are in our formula as well as the n? But that's all for today. That brings us to the end of financial maths for year 9. Thank you so much for joining me, and I'll see you in the next series.